Hello and welcome back to NorCal 715. Today I have this monitor. It is a AVQ270S. Hopefully you can see that up there. And the problem is it just won't power up. So it has this little power supply unit, output 12 volts at 5,000 milliamps. 5 amps output out of this little switching power supply. You can see the green light is lit, so it is producing power. So the first thing I'm going to do is test this power supply and verify that it can produce close to 5 amps at 12 volts. So you may remember this from the customer that sent me a power supply board to be tested. So what I've got right now is I've just got a screwdriver in the coaxial power plug right here, and I've got my positive probe here, my negative probe on the shield of the coaxial power plug. I got it connected to my voltmeter, and look at that, it's dancing around. Now it's unloaded right now, so it's dancing from, let's go to min-max, 12.3 maximum, 11.94 minimum. That's not that much. So it's just over 0.3 of a volt, almost 0.4 of a volt. But I'm going to connect these resistors. I have 12 ohm resistors right here. I have 5 of them. So each one at 12 volts will draw 1 amp of current. And I've got them set up to my little toggle switches here so I can turn them on and off at will. They're all off right now. So I'm going to connect this lead, the purple lead right here, to the positive lead. And I'm going to connect this lead right here, which is my common ground bus, that goes to all the switches commonly, to the negative part of this power supply, the negative terminal on this power supply right here. And we're going to give it some load and see if it can supply 12 volts at 5 amps. So let's go ahead and connect that up. Okay, so the load is now connected. Let's put on 1 amp of load. So it pulls down to 11.1 volts at 1 amp, 10.9 at 2 amps, 10.8 at 3 amps. It's actually less current because we're only at 10.9 instead of 12 volts right now. 10.6 at what would be approximately 4 amps at 12 volts. And 10.5. So I'm going to say right off the bat, we're having a problem with the switching power supply. Because according to the specs, it should supply 12 volts at 5 amps. It shouldn't drop down that much. Alright, so I've got it popped open. And of course they glued the inside of it right here. So I'm going to have to pull the circuit board out. There we go. So let's see if we can find out what's going on with this guy. Why is it not supplying 12 volts at 5 amps as spec? So I've got my Hacko, and I'm going to just unsolder these rectifier diodes right here. In this terminal right here that holds the heatsink on. As well as I'm going to take the switching transistor out. Next, I'm just going to try to gently remove the diodes and the heatsink. I've got it siliconed up in there. I'll have to peel the silicone away. There we go. Pull it loose. Now I can get a look at the power supply board. There's the main filter cap right there. There's a small capacitor here used in filtering. So I'm going to go ahead and ESR both of those. And we'll go ahead and unsolder one lead of these 3 filter capacitors here as well. So I always unsolder the positive lead. And so because there is a inductor right here, it's set up as a pi filter, so it's got these 2 capacitors on one side and this 1 capacitor on the other side with the inductor in the center, and it can give you misleading results. Okay, so I'm going to short my leads together, make sure I'm at close to 0, right at 0, and I want to see minimal deflection on the meter when I go just to the pad like that. So I can measure 1 capacitor separately. That one looks good. Measure the next capacitor, measure the pad first, no deflection. And the capacitor is good. Measure the third pad, no deflection. And the capacitor checks good, 0 ohms, which is what I would expect to see on a large filter capacitor like this output cap, which is a 1000 microfarad capacitor at 25 volts. This is the input part of the pi filter, these 2 caps, through the inductor, and then this is the output capacitor of the pi filter, this one cap, 470 microfarad, 25 volts. So let's go ahead and measure the main input filter capacitor now. Because there's no other capacitors in this network, I don't have to unsolder one of the leads. And it measures about a half an ohm. It's a 100 microfarad, 400 volt capacitor. Let's look at this one filter, 47 microfarad, 35 volts. And it reads 10 ohms. I think a 47 should read a lower ESR than 10 ohms. Normally I would expect to see, regardless of what this ESR limit says, in a switch mode power supply, I would expect to see 1 to 2 ohms on a 47 microfarad capacitor. So let me see if I've got a 47, and we'll test it out of the circuit. So I've got my drawer of 47 microfarad capacitors here, and so I'm just going to grab one of these guys. Now this is a 47 at 63 volts. The voltage is a little bit higher, but that's really not critical in this circuit. Let's ESR it, and it's about just under a half an ohm. Let's grab one of the other ones. We'll use the best that we can find. This one is a 47 at 50 volts. It's about the same. Got some other styles in here. These are just collections of caps over the years. About 7/10 of an ohm. Put that one back. Here's a smaller one. This is the exact value, 47 at 25 volts. And it reads about the same. Let's go ahead and put this one in, 47 at 25, the exact value and exact voltage that came out of the unit. So I'm just going to go ahead and use the Hacko. If you don't have a desoldering iron, you can use a soldering iron just to heat up both terminals of the capacitor simultaneously, and just go ahead and pull it right on out of there at the same time. Now, to clean the solder, you can use a pick, like a dental pick or some kind of a pick. I've got one right here. You could just heat it up and poke it through the hole, let the solder cure, pull it back out, and you'll have a clean hole to put your new capacitor in. Now pay particular orientation to where the positive and the negative is. Now the negative on this board is marked with the shaded area right here, so you know the negative goes on the right hand side, the positive goes over here on the left hand side. Looking at the new capacitor, the positive lead is always the longer lead. So as I rotate this around, you can see the negative lead is the shorter lead. Bend the leads over slightly so it doesn't fall out of the board, and we'll solder it in place. I realize I have my big fat tip on here. I should be using more of a fine point tip. All right, it's in place. I've got my flush cutters. These cut extremely flush. We'll trim it off. Now I'm going to tack the other capacitors back in place because they all tested just fine. All right, all soldered back in place. One of the major problems with these power supplies is high ESR capacitors. So before I connect this back together, let me give you a brief overview of what this power supply does. So the FET, it mounts right here, and it takes this raw after the bridge rectifier. This is a standard bridge rectifier, 2 AC inputs, and a positive and a negative output. So the AC input, AC power from the wall, from the mains, comes in here. It's filtered through a little noise suppression circuit right here. These coils and this capacitor right here remove the transient noise. It goes into this bridge rectifier, into these two inputs right here. These are the AC inputs. This is negative output and this is positive output. So if we take a look at the bottom of the board, the positive output goes right to this terminal right here along this trace, and that's going to be the positive input of this filter capacitor. You can see the negative band right here. The negative output goes across a jumper right here. Through the jumper, it goes into this negative input of the capacitor. So there's a small switching IC right here. That's the controller IC. And so that starts the FET to oscillate, and it just turns on and off briefly. As the FET turns on and off, it causes the field in this transformer to collapse. And so out of these two leads right here, which are the output leads, and there's one more lead that's going to be buried under here that I can't see, it feeds into these rectifier diodes. The diodes rectify the circuit into DC from AC, filters it through these capacitors and this coil and the pi output filter network. In addition to that, it takes a sample through this little lead right here, through these resistors and whatnot, and into this optical isolator. So what that means, it has a little LED on these two terminals, and it has a receiver on these two terminals right here. And so it's optically connected. There's no physical path where this hash is on the circuit board. This is hot over on this side, this is cold over on this side. So that means there's no physical connection from side to side, with the exception of a noise filtering capacitor right here that goes from hot ground to cold ground. That just keeps transients and whatnot away. Now normally all this capacitor is a resistor and a capacitor in one package, and it just helps suppress noise that would build up in between these two units. So when the voltage becomes high enough, over 12 volts, it turns on this optical isolator, biases this LED on, and the photo receiver in here, the photodiode, receives that signal. It feeds it back into this chip right here, and the chip actually controls the oscillation of this FET. It controls the duty cycle of the FET. And so the smaller the duty cycle, the smaller the output's going to be, the lower the voltage. The larger the duty cycle, the higher the output voltage is going to be. So as this unit draws more current, the duty cycle of the switching controller and the FET is going to increase to compensate. So it's a closed loop system. It creates the signal, it passes through the transformer, it's rectified by the diodes right here, and it feeds back into the opto isolator. So it's constantly monitoring itself to verify the voltage is correct. So now the capacitor we changed is in the switching network of this controller. So let's go ahead and get it all buttoned up right now. So it's all soldered back together. I'm going to connect my test leads right here, which is the output of the power supply where it goes into the cord, and we'll hook up my dummy load. I'll bring the fluke meter back out, we'll hook it up, and we'll do some load tests. Okay, as you can see, I have my jumper leads on the output right here. One of the positive leads feeds onto this rail into the dummy load resistors. The other lead feeds into my multimeter input. Okay, so I've got my voltmeter connected. So the positive lead right here connects to the positive rail over here. And then this lead right here connects back to my voltmeter input. The negative lead, the green lead, connects over here. These two terminals you can barely see. And the other terminal connects back to my negative input lead. So here's the flying lead, the purple lead. It's just hanging loose. It's not connected to anything. So all my switches are off on my 12 ohm resistors. So let's power the unit up and see what we get. So on loader we get 12.25 volts. Now last time this was hunting. It was bouncing around all over the place. I'm going to move this back down so you can see that top switch okay. So I'm going to give it a 1 amp load now. 11.9, 2 amp load, 11.6, 3 amp load, 11.4, 4 amp load, 11.3, and a 5 amp load, 11.0. It's kind of moving. It's at full capacity right now. It's producing 11 volts. Which is okay. I'd like to see it 1 volt higher, but at least it's not in the 9 and the 10 volt range. So next I'm going to hook it back up to the monitor and see if we get better results. Because normally this monitor should not draw the full 5 amps. I would expect it to draw in the 1 to maybe 2 amp range normally. So let's get it back connected, see what happens. So I've got it connected back to the monitor. And here's what I'm seeing on the 1.5 amp input range. It's pulsing, which tells me that there's definitely a problem in the power supply in the monitor. So now we're going to have to pull the monitor apart and take a look at the main board because it should not be pulsing at this point. It can reliably supply 5 amps at about 11 volts, which should be more than enough to get the power supply in the monitor to run. So let's take it apart and see what's inside. Okay, so I've got the monitor open. This is the main power supply board. This is the LED driver board. And so I'm going to just do an ohm check on the input right here. Oh, and we get 0.9 ohms. That is very bad. Would not expect to see 0.9 ohms. So let's go ahead and unplug the power from the driver board. and we get 2.8 megs. That's very good. That tells me the problem is definitely on this board right here. So next, I'm just going to remove the screws from the board. This may not be the LED driver. It may just be a power supply board. VCC R10, VCC C6, ENA R11, adjust, and ground are the terminals on this board. This transistor, most likely a FET, looks like it's been running very hot. So let's go ahead and do an ohm check on that. Let me get the rest of the circuit board out of the way and we'll check that. Okay, so let's check this FET, most likely. I haven't checked the number. 0.8 ohms, that is definitely bad. So let's take this guy off the board. So I'm going to put my ohm meter in the diode range and we'll check the source to the drain. It's a dead short. Let's just look at ohms. 100 ohms and 0.8. So I think it's going to need a refill on this FET 19N10. So next I'm going to check some of the associated components with this FET. We have a transistor right here. I'm in the diode range on my meter. I see a junction there. I see a good junction there. All right, so got the board here. I've received some FQD 19N10 FETs and some 47 microfarad at 100 volt capacitors. So we're going to change this one capacitor and we're going to change the FET right here. So we'll go ahead and desolder the capacitor. So get the ESR meter out, short the leads, verify 0 ohms. I'll check the old capacitor first. Absolutely open. We'll check the new capacitor, 47 at 100 volts. Just under 0 ohms, so it's about 1/3 of an ohm. That's acceptable. Next, I'm going to get my MK168 transistor tester. Now with no part, I'm going to hit the test button and just make sure it lights up and it does a self-test. No part, perfect. So we'll get the brand new FET. We just hit the leads up randomly here. Test. It's the in-channel MOSFET, so source, drain, gate, yellow, green, red, which is 1, 2, 3. It has a capacitance of 1.3 nanofarads, and the forward voltage is 3.4 volts. So the new FET checks fine. So the next thing I'm going to do is I'm going to add a very small dab of solder and try to work it around. Now that ensures that the tab portion is going to go ahead and be soldered to the board and have adequate heat sinking capabilities. So before I solder this, I'm going to put a little bit of the Amtech flux on here. So we'll put the new FET into place. Next, we'll take the hot air blower and just go ahead and heat everything up. And if it moves, there's really no problem. We can move it back into place as necessary. So I'm just going to go around and around. I want to try to kind of heat up the tab more than anything, so it takes the solder. There it goes. It just took it. I'm going to make sure my leads are centered where they need to be. There it is. So the tab is soldered to the board. Good. Next, we'll go ahead and just tack these on. I do like to use a little extra solder. Now we'll take the new capacitor, bend the leads down, and I bent them so they don't actually touch the case. You don't want them to touch the case. Now on the circuit board there's a big flat white line, that's the negative. So we'll make sure we get this in here correctly. Bend the leads over slightly and we'll solder it in place. All good. I've got some acetone and an acid brush, and I'm just going to go ahead and clean the flux off of the circuit board. And you can see how that looks. Very nice and clean. So let's put the board back in the monitor and see what we get. Okay, so I've got the board back in it. I'm going to plug the adapter into it, turn the power on, and I don't know if you can see it or not. There it is. Down here in the corner, we get the red light. So next, let's put the LCD display back in the monitor and see if we get any kind of display. There's one. This cable is the LED drive from the LED driver board right here to the LEDs in the panel. So plug it into the LED power supply board. So the LCD's back in it. Let's turn the power on and see if we get anything on the screen. We do. Okay, so I turned off the lights. I have an HDMI cable connected to a Blu-ray player. Let's plug it in. You can see the red light is still on here. Right there. It's plugged in. The red light went off immediately. And we get the setup screen. Let's close the drawer. Ask it to play. Make sure we have audio because this unit does have built-in speakers. Volume up. Alright, we have audio. Awesome. I certainly hope you enjoyed this video on the Atron Vision monitor. If this video has helped you, please consider making a donation on my YouTube homepage with the PayPal donate button or at paypal.me/NorCal715. Everybody have a great day. Thanks for watching. Bye-bye.